Welcome back. Today is day one of our right triangles unit. In this lesson, we will revisit the definition of a square root. We will also find the square root for perfect squares and estimate the square root for non-perfect squares. Hope you enjoy the video. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Today is find the area of a square. Man, this is going back way back. This is going way back. Is there a formula for finding area of a square? Yeah, there's a formula. It's a simple formula. So area is equal to side squared. So really all we have to do is if we know one side of a square, because all sides are the same are in the square. So if you know one side, then you just square that value. So for this first problem, my area is going to be equal to 3 squared, which is, my area is 9. Perfect. So the area for this one is 9. And again, I like to go back to all the way back to area. Remember when we were calculating area, we're really just counting how many squares are in here. So again, if I cut this, I try to cut it as equally as possible. But if this side's 3 and this side's 3, that means there should be 9 squares in there. So I'm going to write down units squared. Okay, so that's what we're really counting when we're finding an area. All right, so let's try the next one. Next one should be nice and quick and simple. So area is equal to side squared. So again, area equals just 5 squared. That's all we have to do because all the sides are going to be the same. So you just have to square the side and you'll get your answer. So the area is equal to 25. So my answer is 25 units squared. So really, remember what we're counting? We're counting how many squares fill up this. Remember, area is the inside. Remember, perimeter is going to be the outside, but area is going to be the area in between. Perimeter is the distance around an object. So there we go. So a 5 by 5, as it looks like that, looks like a nice little grid. So that'll be 25 units squared. All right, but that leads us to our next problem. I really like this next one. So in the next problem, it says these are squares. So these 3 figures here are squares. What is the length of segment AB? So what we're trying to figure out is how long is it from here all the way over to here? So that's what we're trying to figure out. And the only thing we know is the area of each one of these squares. And again, most of my students at this time right now, they'll do this problem by just, if they know the area is 25 inches squared, then they know that they're trying to figure out what number times what number gives me 25. So they're like, oh, 5 times 5. That would tell me my side lengths for this one. And if they're doing it for the bigger square in the center, then they'd be like, okay, what number times what number gives me 49? And they'd be like 7 times 7. And then for the last one, they'd be, okay, 9 is going to be 3 times 3. So this is a great little problem. So now what is the length of segment AB? Well, all we have to do is find the sum of these 3 little pieces. Because from here to here will be 5, the next piece will be 7, and the next piece will be 3. So my answer for that is going to be what, 15? So 15 inches. That's how long segment AB is. AB is equal to 15 inches. Okay, not too bad. Pretty fun problem. I like this one. I like problems like that make me think a little bit about how to do it. Let's try to formalize what you were doing a second ago. So it says a square root is a number n that is a number. The square root of a number n is a number m, so such that m squared equals n. Okay, that's a lot of language, but let's see what they're trying to say. So basically, if you want to find out what m is, m squared, or what the square root of 81 is. So that's what we're really trying to figure out. What's the square root of 81? We need to figure out what number m will make 81. So think about that. What number can you square to make 81? And again, this is going to be really interesting. There's going to be 2 answers. So one of the answers is going to be 9, because what we know is, we know 9 squared equals 81 because that's going to be 9 times 9. All right, but there's a second answer. There's a second answer, and the second answer is -9. It's because -9 squared will also give you a value of 81. Okay, so when we're doing these problems, we're taking square roots. There's, for every positive number, there's going to be 2 square roots. There's going to be the positive value, and there's going to be the negative value. So we're going to have 2 different square roots. So let's try a different one. So if I said, what's the square root of 25? Well, there's 2 ways to get that. You can do one of them could be 5 times 5, and the other one could be -5. So kind of like the same way you've been doing the area problems that we just worked on. All right, so hopefully that makes sense. And then let's see. But now we're going to have some symbols here. Well, a couple definitions that we need to know in here. So let me just highlight. I'm going to skip the words for right now. So this symbol that we use is this one right here is called the radical symbol. All right, so that's the radical symbol. I don't really use this too much, but what we call the value underneath that, that's the radicand, so that's underneath there. All right, and then our solution will be the answer for it. One thing that you need to understand is when we have a radical symbol over our number, because we just said right now literally that there was 2 answers. But look at this. When it says the radical symbol represents a non-negative square root. So this is key. When we write the square root of 25, I don't want you to tell me both answers. You just tell me the non-negative answer. So when I write the square root of 25, you're going to say, oh, that's 5. All right, so if you just see a square root of, you just see the square root of 9, we only want the positive answer. So we're just going to say, there we go. We want that to be 3. We'll talk about this in a second, so I'll talk about that in a second. So I'm not worried about that for right now. And yeah, that's about it. So really, this symbol is called the radical symbol. And usually when we write a square root, we only want the positive answer, not the negative one. All right, so that shouldn't be too tough. Let's take a look real quick about these 2 sets of problems. So the first problem says, what do you notice? So what do you guys notice when you look at this? On the left side, it says find the square root. On the right side, it says find the square root. On the left side, it says square root of 4, square root of 9, square root of 16. On the right side, it says square root of 3, 6, and 10. I mean, the first thing most of my students notice is because they don't like decimals, so they're like, no decimals. That's what they would say, no decimals. And these are decimal numbers. Now, I want to know why. Why is that happening? So why does the fact on the left-hand side there are no decimals, and the right-hand side there are decimals? So here's what's really happening. So when we're looking at these problems, there's something interesting about these numbers. And these numbers actually have a name. So we're going to tell you what these names are. This is 4, 9, and 16. There's something interesting about those. So if we were to take these numbers and make some images out of them, let's take a look and see what we'd get. Well, actually, and these ones also have a name. So I put these together because they both have names. So 3, 6, and 10, they're a kind of fun kind of category of numbers. Let's take a look at what they are. So when I look at this problem, on the left-hand side, 4, 9, and 16 are called square numbers. They're called square numbers. Why do you think they're called square numbers? Well, it's nice and simple and easy to see now, because if we took 4 objects, we can place them in the shape of a square. Same thing with 9. We can place 9 objects into a shape of a square, and we can place 16 objects into a shape of a square. Now, if you look at 3, could we make a square out of those 3 objects? No, we couldn't do it unless we're going to start taking them and cutting pieces off. And really, that's why that makes sense, that we can't make a square unless we cut it into pieces. And that's why those are going to be in decimal form. So again, the cool thing about 3, 6, and 10, though, what do you think those are called? Those are called triangular numbers. So again, It's kind of interesting, kind of fun. There's a lot of fun problems, especially with triangular numbers. There's a lot of fun problems with those ones later on in math, but I wanted to share that. And now, another reason why we can say these are squared numbers is 4 can be written another way. So we can write 4 as 2 squared. Does that make sense? The square 2 times 2 is 4. And we can write 9 as up. And these are called perfect squares. So 9 is a perfect square because we can write it as 3 squared. We can also write 16 as 4 squared. So these are called perfect squares. So 4, or you call them square numbers or perfect squares. But the cool thing about this, if you do that, what you should notice, and you should start seeing something happen, you should start noticing that these square roots just cancel each other out. They simplify out. They cancel each other out, and guess what? Your answer is going to be those values. So the first one's equal to 3 and 4. Oh, sorry. So kind of fun. So you're like, okay, how do we get these numbers over here then? How do we get these numbers? So for these numbers, we're going to need a calculator. So we're going to have to go to a calculator and actually hit the square root of 3. We'll show you that on GeoGebra real quick, but that's... All right, so let's use our favorite app again. So when you want to hit the square root, you can see there's a little square root symbol here. There's a little radical with a little empty spot in it. So let's hit the square root of 3. Let's see what that is. Ooh, this is not good. So right now, let me see if I can change this to... Right now I have my computer set to no decimal places. There we go. So I had to do a little work there to change to get some decimals values, but there we go. So the square root of 3 is approximately 1.73. Let's try the other ones. The square root of 6, I believe, that was our next term that we needed. So the square root of 6. Let's hit enter, and let's see if we can hide some of this because it's kind of jumping down on my screen here. So the square root of 3 is there, and the square root of 6 is right now. And again, another way you can do it also, let me hide this. If I'm hiding my keyboard, another way I can just type in a lot of programs. If you just type in SQRT, that will bring up the square root function for you. So you can just type that in and we can take the square root of 10. And there we go. So again, kind of a little shortcut if you don't need to, if you're not going to use the little keyboard setting. So, or you pop up the keyboard and actually use it from here too. So either way, that would be helpful. Says, can we estimate square roots? And yes, we can estimate square roots, and I want to show you how to do that because again, this is a very valuable skill, especially because if you just want to know like well, think about it this way. If you solve a problem and someone tells you, hey, the answer is the square root of 10 miles, like for instance, how far did you walk, is your walk from home to school, and someone tells you the square root of 10, that doesn't really do me much good in terms of miles. I'm like, I still don't know what the answer is. So it'd be nice if we can estimate and not have to use a calculator and just estimate what that is. So let me show you how I would do that. So on a number line here, we're looking at a number line. Think about 7. 7 is also the same thing as the square root of 49. Does that make sense? The square root of 49 is 7 because that's what 7 squared is. We also know 6 is the square root of 36. So if I take the square root of 36, that should be 6. And again, you should notice these are all perfect squares. So what about 5? Well, that would be the square root of 25. What about 4? That would be the square root of 16. What about 3? That'd be the square root of 9. What about 2? That's the square root of 4. And what you should see is I'm putting a bunch of perfect squares on my number line here. 1, well, the square root of 1 is 1, and the last one, the square root of 0 is 0. Okay, so now, how do we use this fact for estimating? So if someone told me, hey, I walked the square root of 6 miles today, I would be like, well, what is that like as a decimal form, or what can I estimate what that is? Well, I know the square root of 6 is going to be somewhere in between here. It's going to be somewhere right in between here. How do I know that? Well, because on one side it says the square root of 4, and on the other side it says the square root of 9. So I know the square root of 6 is in between there. So what would you estimate that to be? I would probably estimate that really quick to be, I don't know, probably around 2.2. I might be wrong, I might be off by a little bit, but I know it's going to be between 2 and 3 because it's between the square root of 4 and the square root of 9. That's where it falls. So what about the square root of 14? Well, if someone said, oh, I walked the square root of 14 miles, I'd be like, well, what is the square root of 14? Well, I'm going to find my the perfect squares that are next to that. So I look, okay, that's going to be in between here, right? And here, closer to the 16. So I might say that is I'm going to estimate to that to be, well, it has to be between 3 and 4. So I would say maybe about 3.7. And this is how I estimate. I just kind of look what it's closer to. And if I want an estimation, that's good enough. If not, if I really needed a decimal, I would go use a calculator and get the answer. All right, what about the square root of 27? If someone said, hey, I walked the square root of 27 miles today. So I would say, well, let's find that's going to be in between the square root of 25 and the square root of 36 and closer to the square root of 25. So I would say, oh, you must have walked around, and let me mention this now, maybe like 5.2 miles, maybe right around there. All right, I might be off a little bit, and I want you to notice the symbol I'm using. So again, when we say this, this means equal, okay? We know those are equal signs. But when we write our symbol like this means approximately. So that means we are writing an approximation. And that that clears me because I know it's approximately, it's around 5.2. So when we're approximating, we'll say, when we start rounding and we start estimating, we can say that. All right, so again, but the key here is how do you estimate? You're going to have to find square roots, the larger and the smaller square root, and you're going to be in between somewhere in there. All right, so hopefully that's pretty simple. Hopefully you can use a lot of mental math to do that. So for instance, if I said, oh, what's the square root of 101? Well, I know the square root of 100 is just 10, so it must be just a little bit bigger than that. So maybe 10.1 or somewhere a little bit smaller than that. All right, so again, that's how you estimate.